Hello and welcome back to Distance Signal Processing. In this video, I'll explain how to write MATLAB code for discrete Fourier transform in distance signal processing. As you all know, discrete Fourier transform converts discrete sequence to discrete frequency representation. That is, it converts time data into its frequency domain. First, I'll explain how to find DFT by taking a sequence. So let us take a sequence. X of n is equal to 1, 1, 0, 0. The formula to find DFT is x of k is equal to sigma n is equal to 0 to n minus 1 x of n e power minus j 2 pi by n into nk. Here, capital N is the number of elements in the sequence. Here, there are 4. And small n and k goes from 0 to n minus 1. That is, n is equal to 0, 1, 2, 4 minus 1, 3. Similarly, k is equal to 0, 1, 2, and 3. Now we have to find x of k as k goes from 0, 1, 2, 3. So we get 4 values, right? X of 0, x of 1, x of 2, and x of 3. And then sigma n goes from 0 to n minus 1. So we get the summation for as n goes from 0 to 3. So first we'll find what is x of k, that is x of 0. First one. So here k is equal to 0. N obviously is 4. And k, small n goes from 0 to, this is the first case. Now write x of k, it is x of 0 is equal to, first we have to substitute n is 0. So x of 0 e power minus j 2 pi by n. N is nothing but 4. So I can write it as 4. And small n is 0. K is also 0. So into 0 plus next term, n is equal to 1. X of 1 e power minus again j 2 pi by 4. Now small n is 1, but k is same, k 1 into 0 plus x of 2 e power minus j 2 pi by 4, and now is 2, and k is same, that is 0, 2 into 0, plus x of 3 e power minus j 2 pi by 4, now n is 3, k is 0, okay, 3 into 0. Now we can write it as x of 0 is equal to x of 0 into e power minus, this is 0 into 0, so this entire becomes 0. So e power minus 0 plus x of 1 e power minus, this is again 0, j 0 plus, similarly for the remaining 2, so we are, because we are multiplying with 0, x of 2 into e power minus j 0 plus x of 3 into e power minus j 0. Now what is x of 0, x of 1, x of 2 and x of 3? That is the sequence, right? The sequence we have taken as x of n is going from 0 to 3. So this will be x of 0th element. This is x of 1, x of 2, x of 3. So we'll substitute. So x of 0 is 1. X of 1 is also 1. X of 2 is 0. X of 3 is 0. So substitute. Therefore, x of 0 is equal to x of 0 is 1 and e power minus j 0. E power 0 is 1. So get 1. Plus similarly, x of 1 is also 1. E power minus j 0 is 1. So 1. And x of 2 is 0. So this is 0. And x of 3 is 0. So x of 0 is 2. Similarly, we'll find the remaining now x of 1. So I'll write again, n is equal to 4. Now in this case, k is equal to 1 and n goes from 0 to 3 and x of 0, the sequence is 1, x of 1 is 1, x of 2 is 0, and x of 3 is 0. Now we'll write the formula for x of, substitute k as 1. So x of 1 is equal to x of 0 e power minus j 2 pi, capital N is 4, small n here is 0 and k is 1. So 0 into 1 plus x of 1 e power minus j 2 pi by 4. Here small n is 1 and also k is 1. 1 into 1 plus x of 2 into e power minus j 2 pi by 4. Small n is 2 and k is 1 plus x of 3 e power minus j 2 pi by 4. N is 3, k is 1. Now we'll write it up. Simplify x of 0. So this is again 0 into 1 is 0, that is e power minus j 0. Next, plus x of 1 e power, so 1 into 1 is 4, so e power minus, we'll get 2 pi by 4. 2 pi by 4 is nothing but 2 2's, that is pi by 2, right? Pi by 2. Yes, x of 2 e power minus j. 2 into 1 is 2, so 4 will get cancelled. So we'll get pi plus x of 3 e power minus, this is 3 by 2 because 2 2's are 4. So we'll get 3 pi by 2. 3 pi. But we know for the sequence, x of 0 is 1, x of 1 is 1, x of 2 and 3 are 0. So we can ignore this. So we can write it as x of 0 is 1, 1, e power minus j 0 is 1. So 1 into 1 is 1 plus x of 1 is 1. So we'll get 1 into e power minus j by plus x of 2 is 0. So if we multiply 0 with the e power minus j by is 0 plus 0. So simply it is 1 plus e power minus j by 2. We have a formula e power j theta is equal to cos theta minus j sin theta. Right? So now pi by 2 is nothing but the 90, right? So we can write it as 1 plus cos theta. So e power theta, we have the formula as e power minus j cos theta minus j sin 6. So we can write it as cos 90 minus j sin e power minus j pi by 2. We can write it as cos 90 minus j 90. And you know, cos 90 is 0. 1. Yes, this value is 0 and sin 90 is 1. So we get minus j into what? That is minus j is what minus j. Next, we'll go with the k as 2. K is equal to 2 and goes from 0 to. So x of 2 is equal to x of 0 e power minus j, capital N is 4 minus j 2 pi by 4, 0 into 2 plus x of 1 e power minus j 2 pi by 4, 1 into 2 plus x of 2 e power minus j 2 pi by 4, 2 into 2 plus x of 3 e power minus j 2 pi by 4, 3 into 2. So we can write it as x of 0 e power, again this is 0, so minus j 0, right, plus x of 1 e power minus j, this is 2, so 2, 4, so you get minus j, 2 2s are 4, 4 and 4 will get cancelled, minus j. And we know that x of 2 and x of 3 are 0, so we don't need to find out. Now x of 0 is 1, 1 into e power minus j 0 is 1, so 1 plus x of 1 is 1, so we can write it as e power minus j. Now we have to write e power minus j, that is cos of 180, right, minus j sin 1. Rest are 0, so we can ignore them. 1 plus. Now, this is cos 180. So this is equal to minus 1. And sin 180, we know it as c. So we get it as minus 1, minus obviously c. Right? So 1 minus 1 is c. So x of 3 is c. N goes from 0 to 2, capital N is 2. So we get x of 3. Obviously becomes 3, 3, 3, and 3. Now this is equal to 1 into, so this is 6 by 4, or you can write it as minus j p by plus x of 2 0 plus now this becomes 1 plus 1 into e power minus j 3 pi by 2. So you know 3 pi by 2 is 270. So you can write it as cos 270 3 sine 270. Cos 270 is 0 and sine 270 is minus 1. So you can write 1 plus 0 minus j into 270 is minus 1. Minus of minus plus g. So we get it as minus g. So let us see what are the values of x of 0, 1, 2, 1, 3. X of 0, 2. X of 1, 1 minus j. X of 2, 0. And x of 3, 1 plus 0. So we'll write it down. X of 0 plus 2, x of 1 plus 1 minus j, and x of 2 plus 0, x of 3 plus 1 plus j. So this is how we have to find discrete Fourier transform given a sequence, right? X of n. So given a sequence x of n as 1.00, to find to convert this time domain into frequency domain, the formula is x of k is equal to sigma n goes from 0 to n minus 1 x of n e power minus j 2 pi n into small into k, right? So first we have to consider how many elements are there. That gives the value of capital N. There are 4, so n is equal to 4. Now small n and k goes from 0 to n minus 1. That is, we take the values of 0, 1, 2, and 3. So for each value of k, and when n goes from 0 to n minus 1, we have to find the summation. So substitute. And here, x of 0, x of 1, x of 2, and x of 3 corresponds to each element in the sequence x of n. N is 0, 1, 2, and 3. So this is x of 0, x of 1, x of 2, and x of 3. So substitute, find on the formulas, substitute the values, and remember e power minus j theta can be written as cos theta minus j sine theta. So substitute the values in the formulas and then find x of k values. So we got x of 0 as 2, x of 1 as 1 minus j, x of 2 as 0, and x of 3 as 1 plus j. So this is how we can find DFT. Now I'll show how to write MATLAB. So we have to take the sequence, right? X. Take x is equal to. What is the sequence? We have considered 1, 1, 0, and 0. So, next, we have to give the values of capital N and K. N is 4 and K is 0 to n minus 1, that is 0 to 3. So, now, to find the DFT, x is equal to find FFT of your sequence x and then give the capital N value, n. So this is how we can find DFT. So capital X is equal to FFT of the sequence, comma, capital N. Now, you all know what is X, right? X, we are finding X from the sequence and it is a fast Fourier transform. So if you find the value of X, we get a complex number. So let us see, save this file. and run. Go to this X. So we can see here. So we can see here the values of we got after F50. Right? So we already found the values. We got x of 0 as 2, x of 1 as 1 minus j, and x of 2 is 0, x of 3 is 1 plus j. You can see here, say 2 plus 0, that is 2. 1 minus I, here instead of j, it is I, 1 minus I, it is 0 plus 0, that is 0. And 1 plus j, that is 1 plus I. So we got the same one, it is a complex quantity. Now, we can plot, we can have two plots here because it is a complex. We can have a magnitude to spectrum and also we can have a phase spectrum. So let us plot both magnitude and phase. So subplot. So two plots we are going to plot. So new subplot 211. The first one is stem K. Now we have to do the K value. K. We are going to plot the magnitude. So we have to take absolute values for X. Right. So next, second plot is the phase 212, second plot, stem K for values of K, comma, angle, phase is, you can use the function angle for X. So, also give labels, Y label as the magnitude. And then X, Y label for the phase plot as phase. Again, save. Now, here you can see the magnitude and phase plot. So this is how we can draw magnitude and phase spectrum. So I once again repeat how to write the program. Take the sequence X 1100 that we have considered and give the values of capital F and K. Then write capital X is equal to F50 of the sequence X comma M. Now plot the magnitude and phase spectrum. For that, use the function stem. You know, take the values of K because K has to go from 0 to 3. So K comma absolute values for X, and then for the phase stem K comma angle for X. So this is the MATLAB code for TFT. I hope you understood. Thank you.